So, ladies and gentlemen, there was another question concerning the rendering of multiple transparent fragments, and in particular the question was about how to handle more than two fragments. Yeah, and this is exactly what we have discussed on this slide here. So we said when we have an arbitrary number of transparent objects, then the first thing we do, we sort these objects from back to front, meaning with respect to decreasing distance to the view plane, and then we just render the objects in that sorted order from back to front, or we say in back to front rendering. Whenever we render a new object, or whenever, let's become more precise, a fragment of the current object wants to be rendered, then we blend that fragment's color and opacity with the color and opacity that is already in the color buffer. And therefore we use the blend equation given here. So alpha S and CS is referring to the alpha and the color of the source fragment, so the current fragment that wants to be rendered into the color buffer. So what we have here, the product is the effective, we call it the effective color of the fragment, its color times its opacity. Now, and yeah, because that fragment has an opacity, everything that has already been rendered into the color buffer, and because we render back to front, whatever has been rendered up to that fragment is further away from the view plane than this fragment, so it needs to be blended due to the opacity of the currently rendered fragment, and this is just 1 minus alpha s, the blend factor, which is now used to modulate whatever is in the color buffer at that point already. Yeah, let me become more precise and let me do a little example. So let us assume that we have three objects, and we have the first object here with color C1 and opacity alpha 1, the second object with color C2 and opacity alpha 2, and the third object with color C3 and opacity alpha 3. And let us assume we are looking from here. So now we want to determine what is the final color that is perceived along that line of sight, which first intersects the first object, then the second object, and the third object. And we assume that we have a background color, let's call it CB, is equal to 0, 0, and 0. So there's nothing behind these three objects. Okay, now let us write the blending in a little different way as compared to how we have introduced it. Let's just say, okay, the color we now perceive along that ray is just given by the ray first intersects the first object, meaning that what the ray, so to say, gets to see here is the effective color of that first object, which is alpha 1 times C1. Okay, plus, now we can imagine that we proceed along the ray, and the ray now hits the second object. Okay, so now we have to combine the color of the second object with the color that has already been accumulated along the ray, which came from the first object. How do we do this? We apply the blend equation which we have introduced, meaning that we say, okay, whatever comes behind the first fragment is attenuated by 1 minus the alpha value of the first fragment. And this is now the modulating factor for whatever color becomes or is accumulated along the ray behind that first fragment. So we open a bracket here, and in that bracket now comes the color that comes from all the objects behind the first object. And well, how do we determine that color? Well, that color is first the color of C2, because that's the next segment we intersect. So it's alpha 2 times C2 plus, and then we play the game again. We say, okay, whatever comes behind the second object is first of all attenuated by 1 minus the alpha value of the second object. And we take that 1 minus the alpha value of the second object to modulate whatever color comes behind the second object. So times And what is the color that comes behind? Again, we open a bracket to indicate that now comes the color contribution of all the object behind the second one. And that is now, okay, the third one. It's alpha 3 times C3 plus, and again, we use 1 minus alpha 3 as the attenuation factor of whatever comes behind the third object, and that is just the background. So times 0, 0, 0. Now you see what we have done. If I close the bracket here, we have here the application of the blending equation as we introduced it before, by saying, okay, we combine here the effective color of the third object with the color of the background object. And then, once we have that, comes the effective color of the second object plus 1 minus its alpha value times whatever has been accumulated so far. So we can close the other bracket here. And this is what we would then have in the color buffer after, in back to front order, the second object was rendered. And finally, in back to front order, we render the first object. So here we have the effective color of that first object plus 1 minus the alpha value of that first object multiplied with whatever color is in the color buffer already, which has been accumulated by rendering back to front all fragments that are at a larger distance from the view plane than that first object, and that then finally gives the accumulated color C, which we see in the color buffer. Yeah, and the very same blending now can of course also be done for the alpha values if you're interested in obtaining the accumulated alpha value for that pixel through which the ray was traced. Then what you see here is that you can do the accumulation both in front to back and back to front, of course. So here what we have done, I just wrote it down with these opening brackets, because every bracket now indicates the result of the blending, of applying the blending equation for the current fragment and what is already in the color buffer in back to front order, as we said. The first one, first blending, second blending, third blending in back to front order, and this is exactly what we have described on this slide here, by using that very same blend equation here in the back to front order in order to accumulate all the color and opacity contributions.